Any questions about anything before we jump back in? Okay, so I wanted to give a couple of updates on things before we get into our new section here. But I don't think I said this last time, but first test is sort of coming up soon. Want to make sure I have the date right. I know it's a week from this Wednesday, which I think is the 7th. Yeah, so that's when our first test is going to be on Wednesday, February 7th. Basically, it's in the cover from where we started, so section 5.5 up to 6.6. So we're about to start 6.4, so got a few more sections to go. I already posted on my Canvas. I did this late last night, so I don't know if anybody's seen it, but basically there's some stuff to help you review for it, which is already live. But I wanted to make sure I showed you where it was before I went on. So what week are we in? Week 4. So at the bottom of this module, there's an area called exam review. So a few things that I think are useful, because 266 is such a, we run like 20 sections of it every semester here. There's a full website full of like past review problems and stuff. I think the most valuable thing for all of you is going to be this. Basically, it's set up like a Canvas quiz, but it's basically just a bunch of prior exam questions, like a prior exam 1 questions that are good to practice on. Some multiple choice, from some free response. But I would say that should be your first priority for things to review on. I also identified some problems from the textbook to look at. But basically, look through all those things. There's plenty of stuff to look at to kind of get you going for that exam that happens in 9 days. Any questions there?
The format of the exam, is it going to be a bit of free answer and multiple choice?
Yeah, so like exam 1 last semester, I believe, was 8 multiple choice, 3 free response. It'll be something close to that.
And the free responses worth more than multiple choice.
I think the breakdown last time was that the free response was worth 60% and the multiple choice is worth 40%. Once I know for sure what that breakdown is, I'll let you know, but that's what it was last semester. What else? I also put something in here called integration tables, which is something you'll need for what we're going to talk about today. Basically, the book you have access to is basically a PDF version of like the physical book, but the one thing that it doesn't include is, you know how textbooks have like on the front and back covers, there's a bunch of reference stuff. That's where these are, and they're not included. So basically, there's a Word document in that module that has all these in there. But basically, that's what this next section we're going to talk about is how to use these integration tables, and you won't be able to do that unless you have access to them. So they're on Canvas now. What else? Real briefly, one thing I wanted to talk about that I don't think I've made clear enough about kind of the way this class goes is that somebody asked me if it's normal to kind of leave class at the end of class feeling like you don't have what we talked about down, like you don't have it like mastered. And I think that, yes, that's totally normal. In fact, I think it'd be very strange if you did. And that's like, I'm not saying that because I'm trying to do it that way. It's just, like I said on day 1, and I've probably said since then, this stuff is difficult. It's learnable, but it is difficult. And a lot of you learning it has to be done through you practicing it on your own. If I thought this stuff could be learned in 50 minutes without, like, in just those 50 minutes, I wouldn't assign homework, but I don't think that's possible. So, like a lot of things, I say that not to scare you, but to kind of let you off the hook a little bit. If you leave here like feeling like you understood a couple of things or you feel okay about it, that's great. And then hopefully the homework will make it sink in a little more. But I did want to point that out. Like if you're feeling discouraged, try to give yourself a little grace for now. If you have specific concerns about kind of how things are going, let's talk one-on-one, and I can kind of let you know what I think. But in my experience, whenever I do have those one-on-one conversations with people, it's almost never as bad as you think. So if you need some outside perspective, let me know. All right. Anything else? All right. So section 6.4 is all about a couple of things. So integration with tables and integration with CASs, which are computer algebra systems. So basically, there are some handheld calculators, like TI makes some calculators that can basically solve equations for you, that can do integrals for you. Like I think even the very old TI calculators can do like a definite integral and give you a final number. Some of the newer ones can take an indefinite integral and like give you an antiderivative. But some of those things are going to be useful to use, and even if it's just like to check something you've done by hand. So that's something I want to talk about now. So can you see that well enough if I don't actually share it? Probably not. So what about now? Is that visible? Okay. So basically what I'd like us to get in the habit of doing is using these tables. So let's kind of get a feel for like what the tables look like. So basically this reference sheet here, how many are there? I think there are 120 different like canned integral forms that we can use. And they're all sort of broken up into headings. So like these first 20 are mostly things I would expect you to be able to do. Like, so what is number 1? Does that look familiar to anybody? That's integration by parts, right? Hopefully number 2 looks familiar to you. So hopefully the first several are things that you wouldn't necessarily need, you know, this document to give you those integrals for, but they are here. We want to find one that helps us do with this integral. So we have cosine of x over sine squared of x minus 9. So, you know, there are 120 things on here, which is a lot, but it's not exhaustive. I can't write down a table for every single possible function that I might ask you to integrate. So what it tries to do here is to condense them into certain things. So this first heading is the basic forms. Then we have functions of the form radical a squared plus u squared. Is that a good place to look? Doesn't really fit what we have, right? We don't have a radical at all. So we don't have a radical or radicals. Do we see anything on this first sheet that might help us? So I think 1 through 15 are too specific for us, but I do see some of these radical forms here.
20.
What jumps out at you about 20?
It's u squared minus a squared, and if we say that sine of x is u, du would be cosine of x.
Okay, I just realized that I'm showing you the answers here. Yeah, so it did say form to 20 on my notes, right?
Oh.
Yeah, so should have deleted that. Anyway, but yeah, number 20 will work because in the denominator I do have. So here's one assumption they make that you're going to understand that I should probably clear up. The symbols I'm using U and A. What is U in this case? Like what kind of thing is it? It's a variable. How do we know it's a variable? Other than the fact that we're talking about it now. Like, is there anything in the way that it's written that screams out that U is a variable? the fact that du accompanies it. So if u is a variable, what's a? A is a constant, right? So we found the right table. We're going to use formula number 20, but we can't really use it as is. We're going to have to do some kind of manipulation. So let's talk about, in our case, what are u and a? So if we're going to try to mimic formula 20, what are our u and a going to be? U equals sine of x and a equals 3. So just like integration by substitution, if we're going to call something u of x or u, we should have a du that goes with it. What's that going to be? Cosine of x dx. So now that I've done that, can I rewrite this integral? So now that if I rewrite it in terms of a's and u's, what become? Oh, yeah, what does it become? So du over u squared minus. Yeah, so I'll write it 3 squared for now. So do I know what this integral is going to be? So I'll just basically, I'm going to write the formula out with a in place. So 1 over 2 times 3 times the natural log of the absolute value of u minus 3 over u plus 3 plus c. So questions about why we use that formula and how we actually set up the thing that I gave you so we could use it. Go ahead. Yeah. Oh yeah, don't even worry about committing this to memory. Like I said, some of the first few, I'm sure I could ask all of you what the integral of cosine of u is and tell me. But all the ones below this first page, like, no, I can't expect you to memorize these. Are we good here? All right, so let's simplify a little bit. I'll call this 1/6 times the natural log of what? Sine of x minus 3 over sine of x plus 3 plus c. That should be it, right? Questions there? Go ahead.
I know you said most that first bit, but on the test, we still have like 16 to 20 given to us.
Trying to think of the right way to answer this. So there are 120 things on here, right? We will give you the ones you need. We will not give you all these. Guys, some of these are like, especially the further you go down here, they get really, really obscure. Like u to the n times the sine of u du. I mean, and a lot of things are things like, I think when we did integration by parts, we saw that I could ask you x to the 5th power times the sine of x. I could ask you to integrate that, and you could do it by parts. It would take you a while. There's a formula for that that makes this a little easier at the bottom. But yeah, short answer to your question, I will give you the things you need. Any questions about this first one here? All right, how about this one? Let me change the font. Okay, so is there anything on this first page that helps? So we have a radical, right? So the things on the front page that could work for us are what, 16? Does 16 make sense? I mean, it's close enough for us to look at it, right? So what's a good A and what's a good U if we're going to try 16? A is square root of 5 and U is 2x, which means the du would be 2dx. How do we feel about 16 now? Can we keep going or do we need to find something better? Why is this failing for us? Right, so our numerator is not going to line up with what 16 looks like. But what we do know, so what did we learn? 16 is no good. Oh, no. Scroll this. How about this page? Does this page make sense to look through? Right, so this, I have a radical, but I'm adding the terms in the radical, so I think I can skip this page. Does this page make sense to look at? This should make sense to look at, so now we're just going to find the correct one. Why is 34 the right one? Right, so let's talk about all the things that should line up for us. So, for example, 30 and 31 and 32 are no good because the radical is not where I'd like it to be. 34, 35, so the next three might work, right? Except for what? So let's be clear. Why is 35 not a good choice? There's a U outside the radical in the denominator. What about 34? I think we had a vote for 34, right? That should help. We find our A and U and our du. Do those things still hold? Good. All right, so now can we start setting up this integral or start transforming it? Do we have the radical of a squared minus u squared down here? What's the denominator going to be? Sorry, did I say denominator? I meant numerator. So I would love for, actually, let me call this radical 5 squared minus 2x squared. I need u squared in the denominator to make this thing work, right? Do I have u squared in the denominator? Let's just do this in pieces. I'll call this x squared dx up here.
Yeah, would you take out a 1/2?
Take out a 1/2 from what?
What U in the numerator?
The u and then, I'm sorry, maybe I'm not following.
Because your U is 2x,
U is 2x, good.
so could you do U squared up top?
Okay, so u squared,
How would you take out the
okay.
x squared and the dx?
So if u is 2x, then what is u squared? 4x squared? So what can we say about, so the numerator is x squared dx, right? Actually, maybe I should leave the dx off to the side still. So can I call the numerator now 1/4 of u squared?
Yes.
Okay. So let's just leave it kind of clumsy for now. So I have 1/4 u squared over radical 5 squared minus 2x squared. All right, we still have the dx to worry about.
Why is it 1/4 U squared?
Why is it 1/4 u squared? Good question. Why is that?
Gotta deal with the fact that 4x squared is not just x
Right.
squared.
So what I really have in the numerator is x squared, but we're trying to get this integral, just like integration by substitution. First thing we got to do is to rewrite this in terms of our u's to make it work with these formulas. Since I have that u equals 2x, I know that u squared equals 4x squared, which means that 1/4 u squared is equal to, it's really not going to show up, is it? 1/4 u squared equals x squared. So that is how I'm making that substitution for x squared. So let's do one more thing before we're going further. I'm going to pull out a 1/4. 1/4 times the integral of u squared over square root of radical 5 squared minus 2x squared. What becomes of dx here? That should become du over 2, right? I'm running out of space so quickly. Can I call this a du? And can I call this a 1/8?
Yes.
So are we okay now? So it doesn't look very convenient or simple to use the formula that I was trying to set up for. So maybe I should pause here. Questions about how we got here? Go ahead.
I'm a little confused about the 1/4. Like, where did that?
Sure. So let's go back to the kind of our first substitution we set up. Are you okay with the u equals 2x that we declared? So if u equals 2x, then if I square both sides, I get u squared equals 4x squared. And then if I divide both sides by 4, I get 1/4 u squared equals x squared.
Oh.
So remember, our original numerator was x squared. And basically, think back to when we did integration by substitution. We have the same kind of motivation here. I'm trying to get this integral that was all in terms of x. And the first thing I want to do is to get it all in terms of u. So because that's how my x squared became 1/4 u squared. Good question. What else? All right. What does this integral equal then? So we got a 1/8 times something. But now that we've done this, what's the formula tell us? Basically, what does the right hand side of the formula give us? Negative x. How'd you get negative x? Negative u over 2 becomes negative x times the square root of 5 minus 4x squared plus a squared over 2, which is 5 over 2. Of u over a, which is what? 2x over square root of 5 plus c. Doesn't really matter where it goes. But yeah, that nasty thing is our final result. Questions?
Where are you getting negative x?
Yeah, that's a good question. And I'm admitting this. Some of this I'm verbalizing, but not writing down because I ran out of room. Where did this negative x come from?
Negative u squared. I mean, negative u2.
Right. So can you see my cursor right here? Yeah, looks like it's showing up. I don't think I can annotate though. Oh my gosh, I can. That's amazing. Okay, so that's where the negative x comes from. So basically the first term on the right hand side of the equal sign is negative u over 2. So what's my u? 2x. 2x over 2 becomes x, and then I multiply by negative 1. So that's where the negative x comes from. Is that more clear? Okay. What else? So hopefully we're saying the tables are useful, but they don't come for free. You still have to kind of do some manipulation to make them accessible for you. Go ahead.
So how do you know to use these as opposed to some of the other methods? Is it just if it looks like something in the table?
Yeah, so a couple things here. Trying to think of how I might do this without that. Is there a substitution that would work directly? I'm not seeing one. Yeah, I mean, so it's hopefully it doesn't sound like a dismissive answer, but I think the tables are always open to you if you can't, like if you're not seeing, like if a substitution is not jumping out at you, or if you set up integration by parts or even think about setting up integration by parts. See, I'm not even sure what the parts here would be that would make life easy on us. Because either I'm taking the derivative of that radical, which is nasty, or I'm taking the integral of that radical, which I think I might do, but I know it's going to involve an arc sine at some point. So a couple things. The tables are always open to you to kind of give you a push in the right direction. Also, they're useful for, I mean, you can, even if you did do an integral some other way, you can always use the tables to kind of check what you've done. But maybe the tables are useful if you're looking at an integral that is just, yeah, you don't have a better idea on to start with. What else?
Is there a problem where sort of like integral by, by a partial decomposition, instead of doing partial decomposition, we have one of those formulas?
Then you could. I think if it breaks, so the reason that partial fractions work is because you're taking something hideous, complicated, and turning it into many simpler things. I don't think there's a way to do that with either one of the ones I showed you, right? So again, that kind of goes back to Reeves' point. If you don't see another avenue to make the task easier, that's what the tables are for. Is to kind of get you pushed in the right direction. Anything else? All right, let's go again. What do we do here? So let's think about the different headings again. We think this heading might work. So we have two terms. So all of these things in this heading have two terms under the radical, right?
You can factor
I don't think I see one there because I see the radical a squared plus u squared, but I don't see a single u multiplied by it. So that's not going to work. Anything jumps out on anybody? Let's stop. We don't have any trig. Still trig. We don't have any exponential stuff or log stuff.
61.
61. Or 60. What do we think about either one of those? I have some doubts about 60.
Is the Does that, the U that has the N on it indicate that it should be a greater degree than the A plus BU?
You can still use it.
Okay,
You can see, I mean, you have freedom over what you like what N is. What about 54? I had the same doubt about 54 because I'm going to have a squared x under the radical, right?
go back to that picture.
Let's go back to the very top. I was looking for one underneath this heading that had a single, like just a single u multiplied by radical a squared plus u squared. Why isn't it there? 25? Well, here's one thing I want to point out first is that all of these have, so what's underneath the radical? It's two terms, right? Is there a way for me to rewrite this thing, x squared plus 2x plus 4, as two terms? Do we remember a thing called completing the square? Have you heard the phrase? Do you remember how to do it? Vaguely. So basically what the goal of that is, I want to take x squared plus 2x plus 4 and write it like this. X plus a squared plus b. So basically I want part of this to be a perfect square. And then basically I can have the rest of this be a constant. So a couple ways that I've seen to do this. But basically what I want to do is this. I want x squared plus 2x and then plus something to be a perfect square. How do I figure out what goes in that blank here? Ooh, how'd you get that? Oh.
1/2 plus 1/2 times b.
So
that squared.
here's kind of the recipe for doing this. So I have x squared plus 2x plus something, right? I'm going to take that number 2, and then I'm going to cut it in half, and then it becomes a 1. So divide by 2. And then after I get that 1, I'm going to square it, and that'll give me a 1. Can I factor x squared plus 2x plus 1? How does that factor? So that is a completed square now. But I did something illegal, right? I added 1 to this, which means I have to, basically, I added 1 to this parentheses, which means I have to subtract 1 outside of it. So basically what I have is this, x squared plus 1, sorry, x plus 1 squared plus 3. So that gives me this. The integral I'm actually doing is the integral of x times the square root of x plus 1 squared plus 3 dx. I still don't see a formula working here. But maybe we should try something. Is there a good u that I can define? So basically all of these forms are radical a squared plus u squared, where u is the variable piece and a is some constant. Underneath the radical, what's the variable component? Should be, oh, I think it should be x plus 1. And then du will be what? Dx. Does that help me rewrite this? So underneath the radical becomes, actually, Oh, u squared plus radical 3 squared times du. What happens to that x? I can rewrite it in terms of u.
Oh, it's
U minus 1. In my notes, I said I used formula 21 with this, but I don't think I was telling the truth. So let's do this. Let's take this to this would be a good time for me to show you one of those like online calculators. So there are the good news, there's a ton of these. So let me search Wolfram alpha indefinite integral. So sometimes the tables are not getting it done, so you can use these as well. So there's a ton of these. Wolfram Alpha has a lot of these online calculators. Has anyone ever used anything by Wolfram Alpha before? A couple of you. So they're also really good to, even if I ask you to do an integral by hand, it's also useful to check yourself after you're done. Question?
This is just for the class, but I forget where, but on my ASU, there's a place where students get free Wolfram Alpha Pro accounts.
Nice. I don't think I've ever come across something I couldn't do with the free version, but except for that's not playing well with me now. So x times is that square root in the right place?
also square root of the x.
Okay, so let's okay, I'll just cheat this way. Maybe it's not easier to do this. All right. Is there a square root thing on here?
Let's do the same SQRT.
Can't do it that way, but just tap to the left.
Yeah.
Oh, thank you. So x times the square root of x squared plus 2x plus 4. All right, is that finally correct? Not a good sales pitch for this thing. Let's try Symbol Lab. They do good things too. Go away. All right, so there's your solution. So did it give me steps? Okay, so sometimes it gives you steps. So it says you could apply integration by parts. I don't think I would have thought to do that. But then you still have to deal with this integral on the right-hand side here, x squared times x plus 1, so on. So I don't know if Wolfram Alpha will give you steps, but Symbol Lab will. So, okay, Wolfram Pro gives you steps. So I know on ASU apps, there's a ton of things that you get access to for free. So maybe that's worth looking at. So I'm not sure that I don't think I've ever run into a time where Wolfram did not do what I asked it. Symbol Lab they're all over the place. They're just as reliable, but yeah, look into Wolfram Pro on the ASU app, see if that helps you too. In the meantime, I'll try to figure out how you might be able to use one of the tables with number 3. Any questions about the online calculator angle on this? All right, do I want to do one more? Yeah, let's do one more. So back to the tables. So am I even on the right page to look for this one? Shouldn't be. What about now?
Can you make it a little bit?
Oh, yeah, absolutely. Yeah, thank you. So is this page going to be useful for us, do we think? Why not? Right, so I have the constant first. So let's move on. How about now?
Scrolling on,
It's what?
still on the same page.
Really? This happened last week too, it just froze. All else fails, turn it off and turn it on. Yeah, right. Did you say N64? It's not what I think of when I'm too old. I was thinking the original 8-bit cartridges that you've probably never seen. Okay, what page am I on? It's still not scrolling, is it?
There it is.
Is it?
Yeah.
I hate everything. Okay. So now that you're looking at the same page I am, is this the page I want to be on? Maybe go back to the function I actually care about. You think 42? What about 42 speaks to you? Okay, so I have the variable squared in the bottom. So now 42 is a good one to try. Let's start defining things. What are U and A? U is 2y. I think not. Be careful about U. So, and one thing, the reason I'm saying is we know what U squared to be 2y squared, right? Which means U should be equal to radical 2 times y. What's A? Square root of 3. What's du? Okay. From there, can we start rewriting this integral? What does the numerator become? Should be u squared minus radical 3 squared. all square rooted. And the denominator thing we're gonna have to be careful with. What's the denominator gonna be? 1/2 y squared. So let's work toward that. If we know that u equals radical 2y, then I think u squared is 2y squared, which means y squared is equal to 1/2 u squared. So my denominator is 1/2 u squared. What happens to the dy? Should be du over radical 2. So I think that's correct. Let's pull out some stuff. Dividing by 1/2 is the same as multiplying by 2, right? So I think I can pull out a 2 over radical 2 times the integral of u squared minus radical 3 squared over u squared du. So let me stop there. Did a lot of manipulation to get to that place. Any questions about how we got to that place? If we're okay with that, can we do the integral? Do we recognize that 2 over radical 2 is the same as radical 2? So radical 2 times what? Square root of 2y squared minus 3. And I don't think the denominator is going to be square root of 2y. Right. So, oh, sorry, I was looking at the left-hand side. You're right. So the u should be radical 2y.
Square root of 2y squared minus 3. Absolute value.
Okay. I think that's all of it. But the which one? On the far left? I simplified 2 over radical 2. So 2 is the same as radical 2 times radical 2. So that's why that simplifies the way it does. What else? Okay, so that's all for section 6.4. I'll post the web work on it. And I swear I'll remember to actually assign it to all of you. As soon as I get somewhere, I can do it. But yeah, go look through these tables. Go experiment with those Symbol Lab and Wolfram tools. If you have any questions, come stick around. Otherwise, I'll see you Wednesday. Yeah. I thought 6.2 was due last night. I think it's tomorrow. Is that okay? The answer can be no. Would y'all benefit from another day or two on 6.3?
Yes.
Yeah.
Cool. Don't be